Hey everyone, it's Mr. Rosenberg, and in this video we're going to be talking about Chapter 6, Section 4, which is rational exponents. And with this, our objective is going to be to simplify expressions with rational exponents. So first, let's take a look at and talk about understanding rational exponents. So far, we've worked with integer exponents, right? Things like 5 squared, 5 to the negative 2 power, and 5 to the 0 power. Now we're going to work with rational number exponents, or more commonly, we're going to work with exponents that are fractions. So for example, we have 36 to the 1/2 power, and that's equal to 6. We have 64 to the 1/3 power, that's equal to 4. And we have 16 to the 1/4 power, and that's equal to 2. So I just want you to real quick pause the video, see if you can figure out what these fractional exponents or these rational exponents represent. What's another function that we use through math, what we've been using, that can be represented with these fractional rational exponents? So if you figure it out, it's another way we can represent taking the square root of a number. Right, so in general, we say that the nth root of x is equal to x to the 1 over n power. Right, so in this case, if we have a variable raised to a rational exponent, well, that denominator, so the denominator, that represents the number root. Right, so the nth root is x to the 1 over n. Right, and in this case, 36 to the 1/2 power, well, that's equal to just the square root of 36. So here's a question I want you to think about as we go through this video. How could we use these exponents to multiply and divide radical expressions with different roots? So if we had two different radicals that we wanted to multiply together, but they had different roots, how can we do that? How can we do that using rational exponents, where we may not be able to using just radicals? So let's take a look at some examples. First, we want to simplify these expressions with rational exponents. So first, we have 216 to the 1/3 power. So we go ahead, we can take a look. We see that this is, our exponent is 1/3, and in that denominator, we have a 3. So that means we're going to be taking the cube root of 216. And then from there, we just have to take the cube root of it, and the cube root of 216, well, that ends up being equal to 6. Now let's take a look at this one right here. We have 7 to the 1/2 power times 7 to the 1/2 power. So here we need to use our rule that products of the same base, we add those exponents. So this can become 7 to the 1/2 power plus 1/2, right? Because when we multiply powers of the same base, we add those exponents together. So this ends up being equal to 7 to the 1st power, and that's just equal to 7. Or another way we could look at it, if we do 7 to the 1/2 power times 7 to the 1/2 power, that's the same thing as the square root of 7 times the square root of 7, right? And that gives us the square root of 49, which is just equal to 7. Now, let's go ahead, take a look at this third example. We have 5 to the 1/4 power times 125 to the 1/4 power. So we have to go ahead and let's convert this to our radicals. So this will become the 4th root of 5 times the 4th root of 125. And this is equal to the 4th root of 5 times 125. And 5 times 125, that's equal to 625. So now we have the fourth root of 625. And if we were to take the fourth root of 625, we would get that is equal to 5, right? And that's because 625, well, that's equal to 5 to the fourth power.